Use the different quadrilateral shapes in GeoGebra. Click on the boxes to discover the relationships between sides, angles, and diagonals. For each question with a yes answer, place an X in the box. So, you guys, I'm going to show you where to find this in one sec. Okay, so you're all here from the link in Canvas, and what you're going to do is you're going to look at your notes, and it says, for a parallelogram, are opposite sides equal? So, you look at your little picture and click, are opposite sides equal? I don't know why it's being so slow. Hold, please. Okay, now look at it. Once I click that, is this the same as this? Is this the same as this? Yes. So you'd go back to your notes and put a X. Are opposite angles equal? So let's go back. Let's unclick this, and let's look at our opposite angles. Are they equal? Yes. Even if we move it around, oh, won't let me. This is the same as this. This is the same as this. So go back to your notes and put an X. Okay. Do the diagonals bisect each other? Unclick this. These are the diagonals. And look, they've cut themselves in half. 2.9, 2.9, 4.95, 4.95. If the answer is no, leave it blank. If it's yes, put an X. So you're going to do all of these, and then it's going to ask questions about the rectangles. So you're going to go here in your group, and now you're going to click on rectangle and answer the questions. You're going to do this for just a few minutes, okay, until I think you've had enough practice, and then we'll go on. Go. So, with this one, you should have gotten opposite angles equal. Yes, yes. Did the diagonals bisect each other here? Okay. Are the diagonals equal in length? No. Okay, let's look. Here's my parallelogram. Here's my diagonals. This one is 9.9. This one is 5.8. So they are not equal. Do the diagonals bisect the angles they pass through? Well, let's see. Bisect means to cut in half. Does this line cut this corner in half? No. This is 28 and this is 31. Okay. Do the diagonals meet at right angles? Right angles are 90 degrees. Are all of these 90 degrees in the middle? No. So, okay, those three are yes, the other three are no. Did you want to go over, I think we should go over a couple of the rectangle ones. Now, I loved it. One group didn't know what perpendicular was, so they Googled it. That makes me very happy. You all are running around with computers in your hands. If you don't know a vocab word, freaking Google it. Perpendicular means they cross at 90. So it says, okay, are the diagonals perpendicular in a rectangle? So I go to my rectangle, show diagonals. Is this and this 90? No. Okay. Do the diagonals bisect the corners? Are the corners cut in half equally? No. Okay. So I'm going to say no. Normally you would just leave it blank. No. Do they bisect each other? Yes. Okay. Are they matching? Yes, they're the same length. Is there exactly one pair of opposite congruent angles? The answer is no. But there are two. Opposite angles are this. This corner and this corner is 90. They're the same. This corner and this corner is 90. They're the same. So there are two pairs of congruent angles. As a matter of fact, all of them are congruent. Yes. Okay, notice it didn't say exactly two. It just said there are two. All of them congruent. And then the base angles, are the angles down here on the base, are they congruent? Yes, they were 90. So you should be able to fill out this form. Now, here's a summary of what you would get. Okay, a parallelogram. Both pairs of opposite sides are parallel. This is parallel to this, never touches. This is parallel to this. Both pairs of opposite angles, this is congruent to that, and this is congruent to that, are congruent. Both pairs of consecutive angles, consecutive. Does anybody know what that is? Consecutive is one after another. So this angle is consecutive to this angle. This angle is consecutive to this angle. This angle is consecutive to this angle. Does that make sense? Next to each other. Are they the same? No. But guess what they are? They actually add to 180. They are supplementary. And if we had more time in this unit, I would have had you figure that out. Notice, here's a parallelogram. Oops. This was 60, and this was 120. 120 plus 60 is 180. So the blue and the red make 180. The blue and the red make 180. Okay, so that's a parallelogram. Okay, so next, the blank diagonals. I don't know what this is supposed to say. Oh, it's supposed to say the parallelogram diagonals. I don't know where we left that blank. Diagonals bisect each other. They always cut each other in half. Now here's the goal. The parallelogram is like the mom of the next few, okay? This one is the mom, and she had 3 babies. This one, and this one. So they all have her characteristics. But then, so the rectangle has all of these 4 things, plus he picked up 2 more things from his dad, okay? So it says, rectangle has all of the stuff up above, plus all of the angles are congruent. And measure 90 degrees. 90, 90, 90, 90. All of the diagonals are also congruent. So this line is the same as this line. Okay, a rhombus. It has all of the parallelogram stuff, and all of the sides of a rhombus are congruent. Okay, the diagonals, we know they bisect each other because they're up above, but the diagonals are perpendicular. They cross at 90 degrees. Okay, so 90 degrees. And then it says the diagonals bisect the opposite angles. So this corner is the same as this corner. This corner is the same as this corner. Okay? And then the square, really, the square is the child of a rectangle and a rhombus together. Okay, so it has all of those things together. So that means all the sides are congruent, just like a rhombus. All the angles are congruent. They're all 90 degrees. I guess I should say 90 degrees. The diagonals are perpendicular. And the diagonals bisect each other. Okay, so again, the mom is like the head of the family. She had rectangles and a rhombus, and then the rhombus and the rectangle had a square. Now the trapezoid and the kite are basically cousins. They have 4 sides, so they're part of the 4-sided family, but they don't have all the stuff that the other ones have. So a trapezoid only has one pair of parallel sides. this side and this side will never touch if you extend it up. But if you extended these two, they would. So only one pair of parallel sides, and then there are special type of trapezoids. Okay, this is a trapezoid. This is a right trapezoid because the base corners are 90. And then this is an isosceles trapezoid because this side matches this side. And isosceles means two matching sides, two equal sides. And then a kite, like I hope you know what a kite is. It's like a kite that you fly, you know, in March when it's windy. The non-vertex angles of a kite. So here are the vertex angles. This is the vertex angle. The top and the bottom of the kite. The non-vertex angles are congruent, the same size. The diagonals through the vertex angle, what's that supposed to say? Bisect the angle. So this piece is the same as this piece. And the diagonals of a kite are perpendicular. Again, I would absolutely spend some time at home, because you're in high school and you have homework, playing with that website. Because all of these things are what you need to memorize. Now you're lucky, you don't need to memorize, you get to use this on the notes, but you need to understand what it means. Or you get to use this on the test, but you have to understand what it means. So, here's kind of the summary then. Okay? If these are parallelograms, rhombi, squares, and rectangles are inside the parallelograms. They are parallelograms. And then a square is also a rhombi and a rectangle. Rhombi is plural for rhombus. Trapezoids and kites are still part of the family, but they're just cousins. So here's the family tree. It's the quadrilateral cousin, and we literally call it a family in math, so I'm not just making it up. Okay? This grandparent had the kite, the trapezoid, and the parallelogram. And then the parallelogram went on to have the rhombus and the rectangle. So these two have all of the things the parallelogram have. And then the rhombus and the rectangle went on to have the square. So it has all of these things. Okay, so that's how they relate. Any questions? All right, so now we need to practice. I'm going to give you guys about 2 minutes to answer these yes or no questions with your group. Go. Is every parallelogram a rhombus? No. Okay. Is every rhombus a parallelogram? Yes. Is every rectangle a square? It goes this way. Rectangles, every square is a rectangle. Every rectangle is not a square. Remember, a square has to have 4 equal sides. Does every rectangle have 4 equal sides? No, it has these two are the same and these two are the same. So every rectangle is not a square, but every square is a rectangle. To be a rectangle, you have to have this side the same as this side the same as this side, and the corners the same. Well, that happens here. This is the same as this. This is the same as this, and the corners are 90. So every square is a rectangle, but not every rectangle is a square. Questions? Okay. Is every trapezoid a parallelogram? No. Is every trapezoid an isosceles trapezoid? No. Isosceles, the trapezoid's the parent. Isosceles would be that they have to have equal sides here. Every one of these is a trapezoid, but it doesn't work the other direction. Is every kites have to have 4 sides? Yes. Is every rhombus a square? No. Is every square a rhombus? Yes. Do all parallelograms have 4 sides? Yes. So that's it. Now I want you to get in and start a 5.1 homework for just a little bit of time. Go. 5.1 homework. All right, so this is review. A parallelogram is a quadrilateral with two opposite parallel sides, okay? And then what do we know? We know that both pairs of sides are congruent. So now these little arrows mean they're parallel. This side is the same as this side. This side is the same as this side, so 4 tick marks and 4 tick marks means they're the same. Opposite corners are the same. This corner is the same as this corner. This corner is the same as that corner. And consecutive corners, these two will always add to 180. I would fill in the picture because the picture makes more sense than writing it down than reading the words. So fill in your picture, okay? And we know the diagonals cut each other in half. So we're going to look at these two examples. Fill in the missing parts of the parallelogram. So right away, I know this piece. I also know that KM from here to here is 36. I know this is 20. And I know NX from here to here is 8. I'd like you guys to fill in with your group this piece, and this piece. Go. Resume. Rachel, what did you get for this one? 17, because opposite sides are congruent. So this is 17. Keith, do you have a question? Or you know the next one? Okay. Jane, what did you get for this one right here? 20, exactly. Okay. Kim, what did you get for this one? Okay, we'll look at it. We know that diagonals cut each other in half. So I know this piece is 8. How big do you think? 8. There you go. Okay, so that's it. Now let's look at this one, guys. Does anybody want to volunteer one of the colors? Jane. Purple is 45. How did you get that? What's yellow and how? What is it? Yellow? Oh, okay. So that would work. Stop side talking. So she's right, that's 45. I'm going to walk through it for the video. Okay, here's the deal, guys, for time. This yellow, these two have to add up to 180. They form a line at the bottom. So this one is 117. Now there's lots of ways you could get these, so she may have done it in a different way, but then I know the corners of a triangle have to add up to 180. So 180 minus 117 minus 18, and that's 45. Okay. The blue one, guys, how big is the blue one? Everybody go. 63, because vertical angles are congruent, which makes this 117. Now here's the one I think Jane got, which was pretty impressive. This is 18, this is 18, because you have two parallel lines cut by a transversal. And these are alternate interior angles, so they're the same. Then you could find more pieces by knowing, okay, this is 45, this is 45, and you could keep going and maybe even fill out some more. Okay, but it's just the relationships we're looking at. Number 7, find the measures of A and B in the parallelogram below. Okay, well, what did we say these two have to add up to? 180, okay? So 180 minus 127 is 53. And then does anybody have an idea what A is? Yeah, why do you think that is? Yeah, that's exactly correct. And then the vocab word for that is, look, it's two parallel lines cut by a transversal. You're thinking is Y. And they're alternate interior angles, so they are congruent. So that's what I was saying. This is really the last unit because all of these parallelograms are just inside parts of our unit 4. Okay? All right, so this next one then. Find the values of x and y. Well, we know the opposite sides are congruent. So this is going back to what we've done now. We know this piece has to be the same size as this piece, excuse me. So x plus 6 equals 13 minus 6. Oh, that must mean x is 7. Let's see. 7 plus 6, yep, that's 13. Then we also know opposite corners are congruent. So if this corner is 68, y is 68. I could then, even if I really wanted to, although it didn't ask for it, I could find this corner because these two have to add to 180. 180 minus 68, okay, is 12. No, oh, sorry. There we go, 112 and 112. I'm going to break this up. I'm going to say, gentlemen, I want you to solve for y. Boys, solve for y. Ladies, solve for x. And then when you finish, most of you will be able to go on and work on the challenge problem. So I'm going to give you about 3 minutes. Boys, solve for y. You're the blue. Girls, solve for x. You're the pink. And then if you finish, work on the challenge problem as a group. Okay, so boys, did you do this? The blues are equal, so y is 9. Ladies, 6x minus 7, both pink sides are the same length, so you put them equal. You can minus 2x from both sides, or you can minus 6x from both sides, but you should get x's 4. Okay, now let's practice the challenge real quick. Everybody watch this, this is super important. EFGH is a parallelogram. So I know automatically this side's the same as this side's the same as this corner is the same as this corner, so on and so forth. It says I to F is 13. Okay? EF, and this is how you want to do these problems on the test. You want to fill in the picture. EF is 2x plus 10. HG is 4x minus 8. Right away I can see how to solve for x. Okay. HEF, this much is 100. Now this one's tricky. EGF, just this little corner, is 60. And last but not least, corner H, this whole corner, is 2 times y. So let's solve for what I know right away. I could solve for x because I know that 2x plus 10, the red part, needs to equal the orange part, 4x minus 8. And if you solve that, you should get 9. Okay, and I'll leave you up to looking at how I got that that was 9. All right, now it wants EFG. Let's look and see. EFG is this corner. I know how big that corner is. Anybody want to tell me? How big is this corner right here? Not 60. What do these two corners have to add up to? 180, and this one is 100, so it must be 80. Okay, so this corner, and I'm going to fill it in because maybe that'll help me later. This corner is 80. Okay, HGE, HGE. Well, this whole corner right here is 100, right? Which means this corner has to be 100. So if this is 60, the other piece is 40. So HGE is 40. HEG, let's see what that is, HEG. Well, if this is 60, this is 60. They're alternate interior angles. So using the stuff from last unit. P.S. You have next week to retake that test. HI. Well, if this is 13 and diagonals bisect each other, this is 13. HG, if I plug in 9 right here, 4 times x, so 4 times 9 minus 8, and HG would be 28, which means that the top one is also 28. And lastly, solving for y, this whole corner is 2y, but we also know that it's 80. So 2y equals 80, y has to be 40. Okay, so you now have enough to do half of 5